Already taken a look at a few types of asymptotes, such as vertical asymptotes and kind of an extension of that, holes in the graph. Today we're going to be looking at how to calculate horizontal asymptotes of a rational function. So remember again that rational functions just mean a fraction, right? So we're going to be looking at some fractions with a lot of stuff on top and a lot of stuff on bottom. A horizontal asymptote is going to be the limit of the function as x approaches positive or negative infinity. So basically we're just talking about where your graph is going to level out on the left side of the graph towards negative infinity and on the right side of the graph towards positive infinity. And horizontal asymptotes are actually pretty straightforward. There's just 3 rules that you want to remember. So when you have a rational function, so you've got something on the top, you've got your highest exponent on top, and it doesn't really matter what comes after that as long as the highest exponent is written first. And then the same thing on bottom. You've got a whole bunch of junk on the bottom, but you have the highest exponent written first. Doesn't matter what comes after that. You're really just looking at the largest exponent on the top and the largest exponent on the bottom. And you're comparing those exponents. If the denominator is greater than the numerator, so the exponents, if the exponent on the bottom is bigger than the exponent on the top, then your horizontal asymptote is going to be at 0. We call this BOBO. Stands for bigger on bottom is equal to 0. If it's bigger on bottom, it's 0. That's BOBO. Now, if your exponents are like an x squared on top and an x squared on bottom, then what you're going to do is divide your a and b. Those are your coefficients. So if your exponents are the same, you have like a 3x squared on top and a 4x squared on bottom. If they're both x squared, you would just be left with 3/4. Okay, and we call this one Betsy. Bottom equals top, you use the coefficients, Betsy. And last, if the numerator is bigger than the denominator, so let's say up top you have an x cubed, but on the bottom you only have an x squared. If the top is bigger, then there's not a horizontal asymptote, and we call this one botno. If it's bigger on top, there is no horizontal asymptote. Okay, so Bobo, Betsy, and Botno, the 3 clowns of horizontal asymptotes. Bobo, bigger on bottom, the asymptote is 0. If the bottom equals the top, you divide the coefficients. And if it's bigger on top, there is no horizontal asymptote. So let's put these rules into action. Number 1, we've got y equals 5x minus 3 divided by x plus 1. What you want to do here is identify the highest exponent on top and the highest exponent on the bottom. So on the top, you have just a plain old x, 5x. And on the bottom, you also have a plain old x. This would be 1x. So it's a plain x on top, it's a plain x on bottom. This is going to be Betsy. The bottom equals the top. The exponents, right? The x's are equal. The bottom equals the top. So all you're going to do is divide the coefficients. So here my horizontal asymptote is going to be y equals 5/1, or just y equals 5. At example number 2, we've got y equals 4 minus x squared divided by 3x squared minus 7x plus 11. So again, you want to identify the highest exponent on top and the highest exponent on the bottom. So up top, the biggest thing we're working with there is x squared, so I'm going to circle that. In fact, that one is a negative 1x squared. On the bottom, the biggest thing we're working with is also an x squared, 3x squared. So this is another circumstance of Betsy. When you're comparing the exponent, you've got an x squared on top and you've got an x squared on bottom. So the bottom equals the top. you're going to look at those coefficients. So for my horizontal asymptote here, I'm going to have y equals -1 over 3, -1/3. Example number 3, I've got 2x squared minus 3x plus 1 on top, and I've got x cubed minus 27 on bottom. Remember the big idea here, you want to identify the term with the highest exponent. So the term with the highest exponent here is going to be 2x squared, and the highest exponent on the bottom is going to be x cubed. So now looking at the exponents only, which one's bigger? The bottom, x cubed, is bigger than x squared. So it's bigger on bottom. That's going to be Bobo. Bigger on bottom. Bigger on bottom. The asymptote is going to be at 0. So here our horizontal asymptote is y equals 0 because this thing is bigger on bottom. Number 4, we've got y equals 5 over x plus 3 minus 6. And this one's a little bit tricky because you've got two parts, but remember we're looking at the rational part, so I'm looking at this fraction here, and I want to identify the highest exponent on top and the highest exponent on bottom. On the top, we don't even have an x. On the bottom, we have just a plain x. So this is another situation of Bobo. So for the fraction, it's bigger on bottom because you have an x on bottom and you don't have any x's on top. So bigger on bottom, that asymptote is going to be 0. So here we've got y equals 0, but then don't forget about that minus 6 to bring that down. So 0 minus 6, the horizontal asymptote would be at -6. All right, and number 5, we got 2x squared plus 7x minus 1 divided by x plus 4. And we are looking at these exponents. On the top, I've got 2x squared. On the bottom, I have x. X squared is bigger than a plain old x. So this one is bigger on top. So bigger on top, that's going to be botno. Bigger on top is no horizontal asymptote. So this one does not have a horizontal asymptote at all. Now, if something does not have a horizontal asymptote, typically what that tells you is that there is some other type of asymptote called a slant asymptote or an oblique asymptote. And you can watch the next lesson to learn how to handle those.